let's revisit this depth in static fluid and pressure. So here's our square. We've summed our forces that equal 0, and now we've got this nice thing over here. So this is the force of gravity. And these two forces are really kind of the two fluid forces that are on there. So if we sum these fluid forces up, and if P2 minus P1, this turns into P2 minus P1 times A. Oh, I kind of like, this looks kind of familiar. So we look over when we pulled up our pressure in the static fluid, P2 equals P1 plus rho GH. So if we do a little math, P2 minus P1 is going to equal rho GH. Let's plug this into here, and what we get is, I'm sliding over on my paper here, we end up with rho GH times A. So, wait, H times A, this height times this area is also my volume. So I have this formula where the density of the fluid that I'm in times gravity times the volume of my cube or my object or whatever. This is known as the buoyant force. This is kind of equivalent to the normal force of a fluid. Now the guy who discovered this was Archimedes, and it was something about a crown, and apparently it's exciting enough to make you run through town yelling Eureka, buck naked. But anyway, let's take a look at it again. So let's submerge this crown in water. Where's my pink water? Let's have blue water. Here's blue water. All right. The forces that are on here, we now have the force of gravity pulling it down, and now we can talk about the fluids pushing it on there. This fluid force, the sum of these fluids, which I'm going to call the buoyant force. And that buoyant force is the density of the fluid times G times the volume of my crown. So this rho is the density of my fluid. That's this water that's flowing around all around here. This rho v g is gravity again, acceleration due to gravity. And then this volume is the volume of the object, or the displaced fluid. That is, wait a second, this displaced fluid times the density of a volume times the density, this times this is really, so F buoyant, can't see that. F buoyant is rho VG. I moved it around a little bit. That's how this is not how it shows up on your equation sheet. This is how it is. Density times volume is the mass of my fluid that's pushed out of the way. So this really is the weight of the fluid that got pushed out of the way. So what Archimedes did is he was given a crown to figure out if it was made out of gold. He couldn't figure out what the density was because he didn't know what the volume was. When he put it inside the fluid, when he weighed it inside a fluid, the buoyant force was what he was measuring, and he could see whether this was made of gold or not. History doesn't seem to record whether it was or not.